personal cameraman. You like nice slow.
False. All right. We're going to look at example 3, 4, X. My goal is to get through example 6. It's a lofty goal, but we can do it. We already have 1 and 2 done, right?
Yeah.
We can do it. I believe in you. All right. So, fundamental theorem of algebra, what did that state from before? It said that for every polynomial f of x of degree n is greater than 1 that can be factored in the form of n linear terms for the form f of x is a, right? You guys recall that? Memorize it. So what we're going to talk about here is our roots and what can happen if we have an irrational root and what can happen if we have a complex root. So this would be an irrational root because we have a square root, right?
Yeah.
So the good news is, for our zeros, if we know a plus square root of b is a root, and you guys would have done this a little bit in algebra 2, then the conjugate, a minus square root of b, is also a root. You guys kind of maybe just discussed it, probably didn't do a lot with it. So if a plus square root of b is a root, a minus square root of b is a root. And the same is true with your complex. If a plus bi is a root, then a minus bi is also a root. Okay? Now, there's a corollary to this. So a polynomial function, f, of odd degree has at least one real zero. Now here's my question I want you to think about. So if I have an x to the 5th or something with that, and there's a bunch of complex roots, right? How do I know for sure that if it's an odd, it has to have one real root? What do odds look like? They start low or high, and then they go all the way through, right? So at some point, they have to pass through the x-axis. Do you agree on that? So all odd functions have to have at least one real root, no matter what. Do evens have to have one real root? They could have no roots, right? I'm finding my direction with my compass. Because if I have a parabola that opens up above the x-axis, do I have any real roots? I have no roots, right? So keep that in mind. Get off here. Why? Ooh, a circle. This is great TV. I have so much time for this. All right. What's that mean? Let's look at example 3. All right. We have a polynomial with degree of 4.
Yes.
Agreed? A degree of 5. Whose coefficients are the zeros 2, 3i, and 1 plus I. How many zeros am I going to have if it's degree 5?
4.
Well, let's figure it out. We don't know multiplicity. We could only have 3 zeros. We could have 1 zero. You could have 2 zeros. We know it's not 0, though, because it's odd. And we know it's not greater than 5 because it's 5 degrees. Those are the 2 things we know. All right? One of my zeros is 2. If one of my zeros is 3i, I know I have another 0 at negative 3i. Because that's the conjugate. 3i, negative 3i. And if one of my zeros is 1 plus I, what's another one of my zeros have to be? Now, how many zeros do I have? 5. Would there be any more? Can I guarantee that these are my 5? Yep, that's it. All right, we're doing good for time. And example 4 is going to slap us in the mouth, but we can do it. Does this one have a graph too? All right. All right, prepare yourself for this one. You guys like to expand functions?
Not really.
Well, you're going to have to. So, polynomial degree 4, whose coefficients are real numbers, and we have 2, 2, negative 3 plus I, and 1 is my leading coefficient. All right, so let's find the polynomial. What are my zeros? How many times does 2 occur? Twice. So for A, I'm going to do x minus 2 and then square it. Do you guys understand why I'm doing that? Because it occurs twice. Multiplicity, 2. When I hit the graph, am I going to bounce off or go through? Bounce off it, right? Even you bounce, odd you go through. So now, what's another 0 I have? X minus negative 3 plus I, right? Do you agree on that? Do I have any other zeros? Yeah, I have to do the conjugate too, right? So I do x minus negative 3 minus I. That wasn't listed, but we know it is because if that's a factor or a 0, then the conjugate has to be a 0. All right? Are we done? No. This is the start. So let's finish this beast. So do you agree if I expand this out, it becomes x squared minus 4x plus 4? Does anyone disagree with that? Now, I'm going to say it's a lot, and if you don't know it yet, I would learn it. Come in for a win time or something, or look it up online, or you can always FOIL them. But remember, that's a squared, b squared, 2 times a plus b. You know what I mean? There's a pattern that every time that these are squared, it always turns out the same. That's a huge shortcut to do it. You would have seen it in Algebra 2, a little bit in Algebra 1. But the difference of squares, we'll be doing that one. That one comes up even more. All right. Now watch this. You guys want to see something wild I'm going to do with this one? Let's do a sidebar over here. I want to show you guys something neat. We're going to call this a sidebar. I'm going to switch this up a little bit. I'm going to call this x plus 3 minus I, right? Because I'm distributing that negative through. Do you agree on that? And then this will be x plus 3 plus I, right? Y'all see that? Yeah. You want to see something really neat? So someone, Mr. Smalls in front, asked a good question about difference in squares. I'm going to show you how we're going to use difference of squares to our advantage. Could I change this? Think about the problem like this. They both have an x plus 3, right? And this one has an x plus 3 plus I. Is this a difference of squares? Do the first numbers match? Do the second numbers match but are opposites? Yes. So if you try to FOIL this out as a trinomial times a trinomial, it stinks really bad. It takes a long time. But I'm going to use what Mr. Small said and see if we remember a minus b times a plus b. You guys remember what that always expands out to? A squared minus b squared. So for this one, what's my a? X plus 3. So that becomes x plus 3 squared minus I squared. Okay. Now, do you all remember? Because when I'm done foiling this, can I have an I in my answer? No, because what's it tell me up here? Coefficients are real answers. So if you go through and FOIL it out and your I's don't cancel, you did something wrong. Okay? I's got to cancel. Yes. Nice job, Mr. Nick. All right. What's I squared, as that mass man once said? Would be minus negative 1, right? I squared is negative 1. which becomes I heard someone say a plus 1, right? Now this doesn't look near as scary, right? Again, we've done all this before. The problem is to do these problems just takes time and pattern recognition. The remix edition. So do you all agree? Now again though, if I know my shortcuts, makes it a little bit easier. Because what's x plus 3 squared become? X squared plus 2 times 3 times x, which is 6x. What's 3 squared? 9 plus 1, 10. Now, yep. Is there a shortcut to do this one? No! Yeah, photo math. I do not condone photo math. Yeah, I'm just saying. That's how I got my degree. All right, now to FOIL it, I'm going to do first, inside, last. Oh my gosh. You're going to have to make sure every piece hits every piece. You have 9 operations to do. The good news is it's not extremely difficult. It's just extremely time consuming. That's why I said this section, very tedious. Yes.
We're not gonna have. I don't have that.
Or you can do what I do, and I just look ahead, and you get x to the 4th.
You can't do that.
I mean, you can.
You just we don't have the answer key.
Not yet.
We have the answer key.
Answer keys are going to be posted for sale.
You actually should.
What is this, Saxon math? All right.
That's what Soup says. Soup saw the answers next to the daughter.
No, I we gotta go.
Then he became a lawyer.
Okay.
Whew.
Subscribe to that 7-page research.
All right. Hold on, though. So,
Yes.
don't have time to go through this process today, but if you want to try it and check it, you can. Honestly, this one was a beast of a one. The next 2 we're going to do aren't as bad. But maybe. So, but you guys can do it. Let's graph and verify your answer. So I'm going to graph that crazy equation that was just on the screen. Are you guys going to take my word for it? You guys can try it too. I'm just going to put some important points here. Uh, 2-0. Hey, right away though, do you guys see this window? It goes from 0 to 50 for your y, and then -5 to 4 on your x, right? So if you graph it and it looks real goofy, you gotta change your windows.
There we go. Boy, is that crap.
Oopsie. If you don't hit the point, you just make your point bigger. It should look like this. I actually am 20%. We just found out. So, based on this graph, how am I going to find this relative max up here? That's what C is asking for, correct? Oh, never mind. Do you see how C says analyze the graph? When you analyze the graph, what do you think you want? You want relative mins, relative maxes, absolute max and mins. Oh my gosh, you should also know limit behavior, but we haven't talked about it yet, so we'll hold off on that. But do I have any maxes, mins?
You have absolute.
We have a relative min. Do I have a relative min? Where's it at? Or what is it?
So that's
23.95. If you really want to know, that occurs at -2.78. There is. Second, calculate min, right? And do we have an absolute min? Where's that at? It's 0. It's at this point 2, 0. Oh, I'm happy that worked out because what do we know for sure is a 0? 2. And did it bounce? It did. It's like a Tigger because a Tigger is a wonderful thing.
There's relative maxes.
Do we have a relative max?
Yeah.
Yeah, we do. That occurs at negative 0.72, 45.86. And no absolute max, right? It's even. Yeah. Yes. This one only has the 1, but you could have infinite actually, like cosine and sine. You can. You don't have to. Does that make sense? Because technically, yes, but you don't have to. There's many different ways to say the same thing. All right. Now, I'm going to show you guys something else. I'm going to intro it here, and then we're going to talk about it later. Like we did, you know how Unit 1 seemed overwhelming because I introduced you to a lot? So as x goes to infinity, what happens to my graph? As I go to the right, what happens to it? What's y do? Y goes to what? Infinity. And as x goes to negative infinity, what's y go to? Positive infinity again, right? This right here is an intro. This is going to be called end behavior. What's the function do at the end? You might have talked about a little bit in Algebra 2, but it's going to become a big deal in here later because end behavior is going to be an asymptote or infinity, or it's going to be like cosine. You can't tell an end behavior. It doesn't have one because it oscillates between 1 and negative 1.
Right.
Yes, isosceles triangles. All right. What time is it? Do you think we can do this? Oh, we got this. I'm not even worried. Do I look worried?
Yes. Very.
I'm not worried. Look at it, smiling. All right. Find all the zeros and factor. We got to remember how to factor, and we have to know how to factor by grouping in here. So for some of y'all, you might not have done a lot of grouping factoring, but now it's going to come up. Because how else am I going to factor a trinomial? Do we have any skills to factor a trinomial besides grouping? Nope. The good news is, if you see a trinomial, they're either going to list some of the factors or it's going to group nicely. So what do I mean by grouping is, you look at your first 2 terms and you look at your last 2 terms and you see if there's a way you can pull something out of these to make it look like this. Is there a way I can make this look like x minus 3 by pulling something out of it? Okay, so if I pull out an x squared, I get x minus 3. Now sometimes, if this was like 2x minus 6, I would have to pull something out of both. You would have seen this. You probably didn't do a lot of it, though. You did some of it. Okay, awesome. Thanks, Miss Seaman. Now, what do I have to pull out of the x minus 3? Nothing, or a 1. Now, why am I writing I'm pulling out a 1? It's to help me factor it, right?
Yeah.
Do these match?
Yeah.
Yes. So, according to the distributed divisibility property, what can I do with this x squared and this 1? Group them out, pull them out. Get them out of there. And then what's happened to that x minus 3? Nope. Just pull it. Because distributed says that hits both. It's not squared, it's just good. Because it's adding. Only 96 days. All right, so, nope. Now, this right here, I'm finding the zeros. So this is equal to 0, right? So right away, do I have one of my zeros?
Yes.
What is it? 3, right? Now, you see an x squared and a 1. Difference of squares, right? But now that's adding. There's no adding of squares. There's no shortcut. So how do I find this 0? Well, how did I find this 0? You set x minus 3 equals 0. So it's 3, right? So to find this 0, I take x squared plus 1 and set it equal to 0. So I get x squared equals what? Negative 1. Now we're dealing with complex land, right? So back in the day, we would have said no dice. I'm going to square root both sides. We got all the dice. Do you agree that I have to put a plus minus whenever I square root? And what's square root of negative 1 equal to? I. So you have an I? Well, we know that if I is a solution, negative I is as well, right? So even if you forgot to do the plus minus, you're going to get it, right? So those are my 3 zeros. Now, if that was x squared minus 1, that'd be x plus 1 times x minus 1. You have 1, negative 1, 3. How many times is this going to pass through the x-axis? 1. The i's don't show up on the graph, right? When are i's used in the real world? To see. Edit that out. Don't touch that. Come on, Mr. Nick.
10 years down the road, they're going to make this something all-star.
Oh yeah.
Maybe. They'll think something. 10 years by now, YouTube will probably be gone. Just like me from this career. All right. Guys, we're going to do it. One more example. I am not open tomorrow during wind time, by the way, because we're doing SEL lessons, just a reminder. So, on this one, look at this. Look at this. Look at this. What do they tell me? They tell me what one of the factors is, right?
Yeah.
Okay. What else do they tell me? Oh, nothing. They don't tell me nothing. But I need to factor this piece. Right away, though, is there something I can pull out of every piece?
4, 2, 4. Oh, my bad, 2. Yeah.
Yeah, it's 2. So let's do that first, right? Make our life easier. I can do math. I did math once. All right. So do you all agree on that? Now they told us 2 is a 0, so or 2i is. So if 2i is a 0, what else is a 0? Now, this isn't extremely helpful. What you could do with that, I'm just going to give you an option. It's not how I would do it, but I'm going to give you an option. Is you could factor this out, right, and do x, minus 2i times x plus 2, or, well, it's a difference of squares, right?
Yeah.
So you could, oh, that's not squared. Whoopsie. So that would become x squared. Ooh, what's negative 2i times 2i? Or what's 2i squared?
1.
It'd be minus 2i squared if you're doing difference of squares. I'll just show it to you. It doesn't hurt. So that becomes x squared plus 4, right? Now, if you didn't know that to do that, to FOIL that out, you could have done it. But now I know when I group these, what do I have to pull out of my front numbers? And no, hold on. I FOILed this out, right? Now when I go to factor this, we're going to group it, right? Because that's all we know for trinomials is grouping. Now, what do I know I have to pull out of this based on this? In x squared. Oh no, she lagging. She was doing so well. Someone pull. Oh no. I'm going to put a bracket here because it's going to be a big one. And what am I going to have to pull out these ones based on this? A 4. Could I have gotten there without that information? Yeah, because you simplify this one, you can pull x squared. What can you pull out both those? 4, because remember, you simplify them as far as possible. So I'm going to pull out a 4. And it's going to be a plus. Again, you don't have to do this step, but you can if it helps you see how to group them, okay? Yeah, and you can do it to check yourself as well. Like, you know that's going to be one of them. And this becomes what? X. Wait, I can't pull everything, can I? It's 2x plus 5. And is the other one 2x plus 5? Yeah.
Yeah.
So does it work? It worked. Ay. And then do I have enough information here to actually group them out now? And then I'll be done, right? It'll be find the remaining zeros. So from here, I actually don't have to finish this beast because I know what the other factor is, but I just want to show you. Bless you. And that's going to equal 0 to find them, right? Do I know 2 of my zeros right now? 2i and negative 2i, right? I'm only missing 1 0, correct? Yeah. How do I get it? Yeah, when's 2x plus 5 equals 0? Yeah, negative 5 halves or negative 2.5. And you're just solving that problem. Now, if you've done this enough, you just know it's always that fraction with an opposite sign in front, right? But you can always solve it. Yeah. Nope, because that's not 2x. Like if you divide both sides by 2, it would just go away because it equals 0. And 0 divided by 2 is 0. That's only worry about that if it's an x out in front. All right. Whew, that was a big lesson, guys. I'm happy. You know what? I'm proud of Miss Seaman for teaching you guys some grouping, though, because sometimes I've had in the past where this was new.